Let us see a cloud experiment for smart farming using moisture sensor and LCD relay. Moisture sensor is an input and LCD and relay is output. The flowchart explains powering the moisture sensor to 5 volts to the ESP32. And 5 volts to the relay, 5 volts to the LCD and 5 volts to the ESP32 in another kit which is already powered. Now connecting the moisture sensor to ESP32 as input in one IoT kit. And output to the relay and LCD from ESP32 in another kit. Write the code in the Arduino IDE for the desired input and output device selected to perform this event. Include Wi-Fi, Arduino, Arduino JSON, PubSub client for publish and subscribe, and Wi-Fi manager to fetch from the library. Define moisture in any digital pin, here we assign with GPIO39. Initially we assign string for my MAC address and set publish topic. Now inside the void setup we begin the serial monitoring function to set the baud rate. Wi-Fi.MAC address function is used here to store in any variable. Here we use my MAC address. Write serial print function to display the my MAC address value in serial monitoring. Use call function to connect with Wi-Fi. Assign the pin mode function for the input to the moisture. Next we write the function for cloud using MQTT. Now write in MQTT function using string function enter your user and password for the cloud. Similarly, enter your MQTT server ID and port. To set the port and server ID in MQTT we use the default MQTT client function. Now we get the declared my MAC address value in client ID using string function. If the attempt fails to connect with MQTT we write function to re-attempt to connect with the MQTT and serial print as try again in 5 seconds. Inside void loop we write the command to check the Wi-Fi connection. If MQTT is connected it calls the moisture sensor function. Else it reconnect the Wi-Fi. Now we code for moisture sensor function, read the moisture sensor value using analog read command and pass the value through JSON to the client. Wi-Fi.mode function is used to connect with the STA like a hotspot. Using if condition if Wi-Fi is connected serial monitor print is connected to Wi-Fi network with IP. Else serial monitor print is cannot connect to the network. If the result is true with the username and password, it is connected with MQTT else failed to connect with MQTT. Now save the file, verify the program and upload in ESP32. Similarly, include the header files and define the LCD pin to GPIO 13, 12, 14, 27, 26, 25 and 5. Subscribe the topic which we have published in the moisture sensor. Now we write the code in void setup. Similarly, we begin the serial monitoring function to set the baud rate. Wi-Fi.MAC address function is used here to store in any variable. Here we use my MAC address. Write serial print function to displays the my MAC address value in serial monitoring. Use callback function to receive the key value from the published value. And assign the value to the temporary variable. And round the value. Using if condition, if the value is equal to 0 LCD print 100%. Else if it's equal to 4095 LCD print 0%. If moisture value is greater than 0 and less than 2000 and both conditions are satisfied, LCD print 75%. Else if it is greater than 2000 and less than 4095 LCD print 80%. When moisture value is greater than 2500, relay will be activated, else relay will not be activated. Connecting with the Wi-Fi and MQTT protocols are similar to the program written for the moisture sensor. Now save the file, verify the program and upload in ESP32. Here the circuit diagram shows the actual wire connections being used. Connect the selected input, that is moisture sensor, to the 5 volts power pin and the input pin to the GPIO 39 pin in one kit. Connect the selected output LCD to the 5 volts pin and LCD pins to the GPIO 13, 12, 14, 27, 26, 25 and 5 pin, using RMC 8-pin cable in another IoT kit. Power both the IoT kit by connecting the adapter. Now dip the moisture sensor in the water and see the moisture in another kit. Soil moisture sensors measure the volumetric water content in soil. Drying, and weighing of a sample. Soil moisture sensors measure the volumetric water content indirectly by using some other property of the soil, such as electrical resistance, dielectric constant, or interaction with neutrons, as a proxy for the moisture content. The 2x16 LCD, which is an electronic display that has 16 characters per line, and there are 2 such lines. It is widely used in an extensive range of applications like mobile phones, automation products, calculators, fuel dispenser, machineries, etc. Relays are electrically operated switches that open and close the circuits by receiving electrical signals from outside sources. They receive an electrical signal and send the signal to other equipment by turning the switch on and off. Relays are normally used in the control panels, industrial automation and automobiles to control the power along with switching the control circuit.